Nvidia, a company that is known for gaming, graphics cards, right? Like I've got one on my computer right now from them, a 3090, yeah, be jealous. But I bet you didn't know this. They're involved in something that I love even more than gaming. Networking, cybersecurity, yeah, and they're not just involved. They're kind of changing the game completely. And they're creating new tech that's kind of crazy. Things like DPUs, or data processing units, which will help us do more with networking and cybersecurity and even AI than we ever thought possible. Sounds kind of cool, right? Like hard to believe. So that's why I invited the SVP of Networking from Nvidia, Kevin DeierlIng, to come on and tell us all about it. Because yeah, I've got some questions like, what the junk is this? How is it working? So, buckle your seatbelts, grab your coffee, let's dive into pretty much the future of networking. Kevin, who are you?
So I'm the SVP of Networking at Nvidia. I joined through an acquisition of a company a little more than a year ago called Mellanox.
So I'll be the first to admit, and a lot of my audience probably thinks the same thing, we didn't know Nvidia was in networking. I mean, I've got my Nvidia graphics card behind me in my PC, but like networking, when did that come into play? So that's pretty cool. So why Nvidia getting into networking?
Yeah, so we're now the largest provider of networking at the 25 gig and above speeds. So we're the #1 Ethernet NIC provider at these high performance speeds. And we also produce a technology called InfiniBand. And that's the world's leading HPC, so high performance computing and AI networking technology. And why? It's because you can't solve the problems and build a data center without networking. And all of the problems can't fit in a computer anymore. We have to think at data center scale. The data center is the new unit of computing.
Which, there's such an evolution of how that's happened, right? So like, I know with, I'm very traditional networking. I love my switches and my routers. I love my hardware. That's vastly changed over the past 10 years or so to where it's all software-defined networking. We're actually putting it on the server. A lot of people probably understand that already, but I just had to say that so we catch them up. We're no longer dealing with network hardware. We're at software on white boxes or just on standard or server hardware now. But real quick, before we talk about what it is that you guys are doing, which is crazy. It's the Bluefield, DOCA, DPUs, and all that kind of crazy stuff. Before we talk about that, what's the problem we have right now with SDN? What's the wall we're hitting that's preventing us from accelerating and doing awesome?
Yeah, so this is kind of like goes back to Anderson's. Now it's almost a decade ago that he talked about software is eating the world. And what's hidden in that statement, it's true. It's totally true. It's transforming industries, including networking. And software-defined networking is an example. So SDN is certainly an example of that. But ultimately, software needs to run on something. The point here with software-defined networking is, well, they said, well, let's just run it on what we have, which is a traditional CPU. And it turns out that you get all these great benefits of software-defined networking, which is flexibility and scalability, and you can use modern software, continuous integration, and continuous development techniques, CI/CD, but you're still running on the wrong horse. Different horses for different courses. And in this case, the CPU is actually not very good at running software-defined networking. That's the problem.
Which is interesting because I come from a Cisco background, and I know that when Cisco designs their switches, they have like ASICs, chips designed just for switching packets, switching frames. And that always was at the back of my mind, like, okay, if we're moving all this stuff to standard server hardware, are we missing something here? And I feel like that's probably it, right?
That's exactly right. So, if you look, the traditional approach to this has been to develop a custom ASIC. But even for very large companies, trying to develop a bespoke custom ASIC for a specific function, whether that's a firewall or a storage box or a software-defined networking box, is really hard. And you're subscale. You're not a semiconductor company. You're not cranking out chips at the latest process node every single quarter. We push a ton of chips through this pipeline, this massive engineering investment that we make. And so we can build a chip that really is even better than a custom ASIC. So it's software defined and hardware accelerated with our DPUs.
Okay. Now that all sounds amazing and sounds geeky, and I want to get really, really into the weeds on that. So explain to me what you guys are bringing to the table. So we have the data center, and we have our servers that are now running the network as well. It's all just one big blob of everything on the same hardware. What are you guys adding to the picture to solve our problem of like we just can't switch the packets fast enough, we can't inspect things fast enough? What are you guys doing?
Yeah, so you described Nvidia perfectly. You said, "Hey, you're a GPU company. I know you guys as the graphics processing company." And over the last decade, what we've seen is the rise of the GPU to be able to do accelerated computing workloads,
Oh yeah,
AI.
Bitcoin, right?
Yeah, really AI and machine learning. That's the big breakthrough. People think about other stuff, crypto and currencies, but it's really AI and machine learning. That has been the transformative trend. AI is the most powerful technology force of our time. And so the CPU simply isn't good at running AI and accelerated workloads. So instead of having the CPU centric server box, we really think about the data center as the new unit of computing with the CPU and the GPU to run AI and machine learning workloads, and now the DPU or the data processing unit to run all those things you just asked about. Data intensive, packet switching, packet processing, encryption, compression, all of those things. It turns out the CPU is really bad at running those. And instead of using a custom ASIC to do each of those functions, we can run software-defined networking, software-defined storage, and software-defined security on the DPU. So really, it's all three together, the CPU, the DPU, and the GPU that is building this new data center as the new unit of computing.
So I want to break, because like I know for a lot of my audience, it's gonna be like, okay, that sounds cool in theory, but like tangibly, what does that look like? When you're saying, okay, we know what the CPU does and we know what the GPU does, but then we have this DPU. Is that just going to be like on the same chipset, the same motherboard as this server? Where's that going? Where's that living at?
Yeah, so right now we're just plugging that in to a server and we're putting a computer in front of the computer. And so when you have a bunch of virtual machines, you actually need to switch between them. You can do that in software running on the CPU, and you get really lousy performance. And when we talk about performance today, 25 gig is sort of the entry point, 100 gig, 200 gig, soon 400 gig into every server. Our big DGX boxes with lots of GPUs in them, we have 1.8 terabits per second of bandwidth going into that box. So trying to imagine a CPU that's able to process, even just to look at the data, let's say it's a denial of service attack. If it has to look at every packet just to throw it away, it turns out you brought the CPU to its knees. Running a DDoS mitigation brings it to its knees. It actually accomplishes what you're trying to prevent. And we can do that with zero CPU load.
Actually, another YouTuber friend of mine, David Bombal, he was testing 40 gig between two computers, and he was doing file transfer test. And you probably guessed what the bottleneck was. It wasn't the network. It was the CPU that just could not handle the file transfer. So yeah, data center's no different, right? Like that's going to be the bottleneck. So what's the magic of this DPU? What's it actually doing?
Yeah, so it does software-defined networking, software-defined security, and software-defined storage. And it does all of those with hardware accelerations. So we have a bunch of CPUs, embedded CPUs inside of the DPU. So we have a ton of ARM processors, and they're super interesting. However, it isn't actually the magic of the DPU. The magic is in those accelerators. So you talked about trying to run the file transfer. We accelerate storage. We do that with zero CPU load. We don't even use the ARM processors to transfer files. We use a technology called RDMA, and we can move at line rate. We can move at 100 gigabits per second or 200 gigabits per second, file to file, without involving the CPU at all.
That's crazy. So okay, I'm trying to wrap my mind around this. So like, we're not involving a switch at this point. It's just the DPU doing the job, offloading that in an SDN architecture. We're talking like VM to VM, transferring files, and it's at line rate. That's what we're talking about?
Absolutely, absolutely. And so the DPU, that's the great thing. We talk to ordinary switches. So we can talk to our own switches or other people's switches and communicate across the entire data center at super low latencies. But the real magic, we like to say offload, accelerate, and isolate. Those are the three things that the DPU does. Offload is simple. We just take tasks that were running on the x86 and we run them on the DPU. However, if we simply ran them on the embedded ARM processors, we actually wouldn't achieve the kind of speed up that we talked about, because the x86 cores are pretty good at doing what they do. But it's that second piece. So we say offload and accelerate. We have accelerators, hardware acceleration, to do security and storage and networking. So when we move the files, it's our accelerators that do that. And then the last piece, isolation, is really related to security.
Okay. Well, so let's talk about security, because I saw some cool use cases, especially from one of the companies I've loved using in the past when I actually had a real job, Palo Alto. I saw they started to use this technology, this Bluefield. What's the official name for this, by the way? I know it's data center or DPUs, data center. What is it again? Processing unit or?
Yeah, it's a Bluefield data processing unit.
Okay, gotcha. So Palo Alto started doing this. What are they doing with this now?
Yeah, so you asked what was the problem with SDN, and all of the companies like Palo Alto, who's a leader in building firewalls, to look at all of the traffic. And it's not just a traditional firewall where it was ports that you would block. It's actually looking inside of the packets, doing deep packet inspection. And when you start to do that, it turns out the problem with software-defined networking or software-defined security is that the CPU is not that good at it. And if you have a 100 gigabit per second link, you'll bring the CPU to its knees at about 10 gig. That's about what you can achieve. So what we did, working with Palo Alto, we have this platform, our software API called DOCA, and they were able to leverage those accelerators. So they took their software-defined networking and they did something that they called ITO, which is actually their offload engine. So it offloads the traffic to the DPU, and the DPU can inspect the traffic for them. So looking at all the packets and the headers and analyzing what the flow is, and decide which of those things that the CPU should look at and which we can forward or redirect or run a load balancer, all of those things. And as a result, we got 9 times better performance. So now we're close to 100 gigabits performance. And we used up 0 CPU load to do all of that ITO, that acceleration that we're doing for the firewall.
Wow. So like I just can't get my mind around that. It's like 0 CPU usage on that. It's not hitting the CPU at all. It's just offloading all of that. Because I know that's an intense process, inspection, especially at that level where you're trying to look at all the different types of traffic, encrypted, non-encrypted, scan it for viruses and everything. Like that's a heavy lift. And you're offloading that to that DPU. That's a little crazy.
Yeah, so this is what's so great. You just nailed all the things that we do well. And it's things that the CPU doesn't do well. So if you use a CPU to try to inspect the packets and look at where it's coming from, or to decrypt the packet, we can bring a CPU to its knees running something like IPsec or TLS. And we do that with software-defined hardware accelerated with 0 CPU load. And so I call it infinite efficiency. You get 10 times the performance or 50 times the performance with 0 CPU. And 50 times the performance divided by 0 is an infinite efficiency gain. Now I'm cheating a little because we're adding the DPU. But when we do the analysis, these parts pay for themselves. You use thousands of fewer servers in a mid-sized data center, and you're getting the same efficiency from that data center. So this is the thing that's really great. We see the customers that are adopting this first are the hyperscale guys, the cloud guys, because this rips right down to their bottom line. What do they sell? They sell CPU cores to their customers. And if they're chewing up 30 or 40% of their CPU cores running their data center infrastructure, their software-defined infrastructure, those are cores they can't sell to their customers. So this rips right down to their bottom line. They've been the early adopters of this technology, and now we're bringing it to the mainstream. Super exciting to be able to deliver this to all of the tier 2 cloud vendors as well as enterprises. So really, really exciting for us.
And what's funny is like everyone's like SDN. This is like the solution, the savior to like what we've been looking for. I didn't anticipate this problem, and I was watching some of the videos on this. And I heard a metric like 1/3 of the compute we have is dedicated to SDN. Like it's sucking up all of that. I'm like, that's a lot. So it totally makes sense to offload that to a DPU so you have all of that. I didn't think about a cloud case like that where, yeah, they sell us the CPU cores. That's what they get off on doing. And goodness, that's gonna save a ton of money in that realm. That's weird. So you mentioned though, because that's the question I had when I heard this. DPUs, Bluefield, sounds like a very high tier, like people like AWS and Google Cloud and Azure will be interested in this, but you said enterprise customers too. So what type of companies would have this in their own data center?
Yeah, so I think anybody who is looking at lots of data and has a requirement for service level agreements. And what happens is that's everybody today, because AI is everywhere. Every business is becoming data driven and every business is becoming AI. So if you are running a workload like, that requires speech recognition, or you're doing something at the edge in manufacturing, and you're using robotics and cameras and analyzing images. If you're doing anything, here we are communicating across a video link. Okay, people are streaming video across their networks. In all of these different applications, it turns out you need to deliver packets really, really nicely and precisely. We have something called the time synchronized data center called Chronos. It's part of our DOCA package. And Chronos actually has precision timing built into the network cards. It turns out when you watch a movie at home and you're streaming over the top, if you've unplugged, you need to get a file. You're just downloading a file. It's called, happens to be a movie. You need to download it not fast, but really slowly at precisely the rate that your home is able to receive and display the data. And everybody's home's slightly different, and everybody has a different TV or whatever device they're using to watch it. So now imagine trying to do that for 100,000 homes in software, where you're counting out the packets and timing them. We have a technology that's called packet pacing that will do that across 100,000 homes very precisely, very accurately. So really any business you can imagine needs hardware acceleration. So software defined networking is fantastic, except it chews up all the CPUs. You want to run your CPUs to run business applications. That's what your business is. And all of that infrastructure, that's what the DPU does for you. It accelerates it.
I love that example of the streaming, because like we all watch Netflix, we all binge, but you don't think about how these companies can accomplish sending all those streams to all these thousands. Like I think Disney just announced they have like 1 million Disney Plus subscribers. I can't imagine the infrastructure behind that. I'm sure you can, but I can't imagine what they have. Being able to timely deliver those packets is insane. Now, what are some other things that are involved with and you mentioned DOCA, like, so let's talk about DOCA a little bit. 'Cause like I know we have Bluefield, the DPUs, but DOCA is all about empowering developers to actually build on top of that. And that kind of, I'm going to ask you two questions at once, and you probably answer them perfectly. So SDN, I know SDN to be like software that various vendors provide for us, like Cisco, Palo Alto. There's a ton of them that do it now. Are they going to be using things like DOCA to be able to build on top of these DPUs?
That's exactly right. That's how we'll enable all of our partners. And we have an analogy in the GPU side of our business, which is called CUDA. And so CUDA is the framework that people can develop all of these AI and machine learning, and it really allows them to benefit from those GPUs. And the same CUDA programs that ran on GPUs that are 10 years old will run on our latest, greatest Ampere today. So DOCA is for the DPU what CUDA is for the GPU. And DOCA is this open SDK interface and a ton of libraries and reference applications that run on top of that. And what it lets us do is take things like our Omniverse, which is a digital twin of whatever you want, and run that on top of our GPUs and our DPUs, exchange data extremely quickly, very, very large data sets. The amount of physics that we run to create the Omniverse is just incredible. So Omniverse is an amazing tool.
It sounds like you're making all this up. It sounds very sci-fi. Like I'm reading a script from Marvel or something. The Omniverse. Speaking of sci-fi, I was watching this video about your thing called Morpheus, which killer name. That's cool. But I saw it was showing AI-driven analytics into cybersecurity, and it's showing all these like strands of like fiber hair branching out and analyzing all these streams of packets and connections. Talk about that a bit. Like, what is that doing?
Yeah, so Morpheus is a really cool cybersecurity application that benefits from the DPU and the GPU. And that's what we're really seeing is the synergy between the networking side and the AI side of the business. So if you think about what's happening in a complex data center today, when people accidentally move from a development environment to a production environment, they can have their login credentials for, exposed to the entire world. And suddenly somebody can take over, 10,000 virtual machines somewhere in the cloud and start doing something that they probably shouldn't be doing.
That never happens.
Never happens. Never happens. You never take your GitHub credentials and accidentally expose them. But you think about all the threats, most of the time, it's actually not being hacked. We have hardware that can detect malware, and we can run that in the background constantly and detect that. But actually, most of the time, it's just operational procedures that you inadvertently expose somebody's password or their credit card number or social security or health records or your own passwords. And so it's really hard in today's environment to just look at log files. I looked at some of these log files. They're just massive, and you can't even imagine a human being figuring anything out.
Oh yeah, we have entire industries dedicated to log file ingestion. It's crazy.
Exactly. Yeah, so what we've done is automate all of that, and we put AI on it. So instead of having a specific set of rules that say, I'm looking for this problem, there's always this question after there's been a breach. It's like, well, did we have a rule to look for that? Well, no, because otherwise we would have found it. So AI, we can make these much broader rule sets. Hey, we're looking for things that look like this. We're not saying where they are or when they might occur. We're looking for humans that are behaving like machines, or machines that are behaving like humans, or things that are being sent that look like they shouldn't be sent. We're not defining it precisely. That's the beauty of a neural network and AI. And so the Bluefield is generating all this telemetry data on all of the packet information. And it's sort of our camera into all of the network activity. You can think of it as a probe, or sometimes you call it a span port in the networking world. We actually are doing that in software, sending data to the AI, and then the AI is crunching it and saying, hey, this looks a little fishy. We're going to quarantine this. And now you can start to actually open and close that aperture of what you want to look at. So really cool technology.
That is intense. So yeah, I know, like that's a big industry. Just being able to detect the issues, like, and you're so right. Like, the big hacks mostly are not like these genius hackers who just hack the mainframe, right? It's mostly people making mistakes. And I mean, for anyone in infrastructure knows how easy it is to make a monumental mistake just going from development to production. And that's not just like programmers. That could be a network engineer making a small change. Whoops, I left my credentials in plain text somewhere. Like, that's so easy to do. So my goodness, having something like that can like, and I saw one of the examples where it showed it was analyzing for encrypted traffic, and it suddenly noticed that a normal encrypted traffic, flow was actually unencrypted randomly. I'm like, okay, what's going on there? And it found it, turned it red, alerted it, and you can connect that to other software like ticketing applications or remediation applications that can help the team solve the issue. That's wicked awesome.
That's great. It's exactly right. Because, we just call that good security hygiene. And it's really hard for human beings to just detect everything. And so what we want is you to sort of describe what that hygiene looks like, what the behavior is that you want, and then let a machine enforce it for you. You don't want to be looking at Splunk log files. Splunk was somebody that we worked with on Morpheus. You don't have to look at just network traffic. You can look at log files and then detect all kinds of things. Half the time you're looking at different log files, they're breaking, they're changing. Trying to have a fixed set of rules to look at them is impossible. And so using AI to solve this problem is really just the smart thing to do, and it's the only thing that's going to work looking forward. It takes AI to fight cybercrime.
Yeah, absolutely. Now with DOCA and Bluefield and all the DPUs and stuff, we know what we're looking at now, what it can do. What do you think it's going to do? What do you think it's going to do for the industry? Because I know your team is probably all about looking forward and seeing what can we do with this and developing for that. What do you think is going to happen?
Yeah, so you've asked the perfect question for DOCA, because that's really what it's about. It's about protecting our developers' investment in applications. And so our goal with DOCA here is to accelerate the innovation that our partners are doing on top of this accelerated framework. for both the DPU and the GPU. And now we need to protect that investment. So we're going to have Bluefield 2, soon Bluefield 3, Bluefield 4, which adds GPU capabilities and AI into a converged platform. And what we want is that all of the programs that are being written today will run on those future programs. And today we just released the first version of DOCA. We announced it less than a year ago. We released the last one in April. We just released the 1.1 version of that. As we go to 1.2 and 2.0, we want all of those new capabilities and accelerations to be available for our partners. So you were asking about, different companies that are going to develop, storage companies, networking companies, security companies, ultimately people that are building the omniverse, this digital twin of anything you can imagine. We will create a digital replica of it and allow you to simulate. You wouldn't build things today without having that simulation environment. We're simulating everything, including the data center.
I'm just trying to get my head around this. This sounds so crazy. And as I learn about this stuff, I'm thinking like, what's it going to change for like jobs? People looking into like becoming network engineers, and all network engineers are kind of developing developer skills, learning Python, learning development. People who want to start developing on DOCA, the SDK, is it mainly focused on networking? Like, is this becoming like a new kind of job sector, like network developers who work on this kind of stuff?
Yeah, I think, the great thing is when I started off, I was a chip designer and I was dealing with transistors. And at some point you jump to a higher level of programming of chips. We designed chips not at the transistor level, but we wrote a language. And I see the same thing happening here with DOCA and the Bluefield DPU. So all of that expertise that the networking and IT administrators have gained over their careers is absolutely vital to understand what you're trying to do, but it makes you more efficient. It lets you program at that higher level. And so even things like regular expressions, we can start to do regular expression searches. So if you're using the Python regular expression, we can accelerate all of that with the Bluefield. It has an engine that does that. If you're looking for giant malware signatures for attacks, you can just program that library and we'll give you a much higher level framework that you'll develop on top of, but you need to understand what it's doing to use that. And so we have a lot of activities now on training. You can go to our DOCA and download it. That's part of what we do well, is really engage with our partners, because our goal here is to help people to innovate faster.
That sounds really interesting. Now I saw this. I was watching a bunch of videos on this DOCA stuff, and DPUs, and I saw that you have this Nvidia platform where it's like cloud gaming, and I saw that you're about to start using DPUs with this. Can you talk a bit more about that?
Yeah, so what we have is what's called our GeForce Now platform. And what it is, it's a cloud gaming platform. There's millions of users that can log in. So instead of needing to own the best games for every single copy that you might want to run, we let you do that in the cloud. And so you get a service. So think of it as gaming as a service in the cloud. And so we have these killer GPUs that we build into our cloud, and then we let our customers log in. And again, now you're talking about an interactive environment where, you've got a joystick and you're playing a game, and we need super precise quality of service. We need low latency and all of that performance. But we have to have anything that's exposed to the internet. You have to be able to protect against people that are externally facing, because there's going to be all sorts of attacks. Anything that's facing the internet, sooner or later, it's going to face an attack, and you need to be able to mitigate those.
Now with I know cloud gaming, it's been like a cool concept, but I know a lot of people are like, it's kind of a weird thing, because I know we've had things come out in the past like 10 years and people have tried it, like Google Stadia or something, and it hasn't been very well received. It's like there's latency and it's crappy. How will DPUs and all the things you're doing with GeForce Now helping with this?
Yeah, so one of the things that we think is interesting about GeForce Now is it really is the same sort of experience. We're giving you a seat on the server. And so other people are doing things with, not really giving you access to the server. And in our case, we're doing that. We're creating a VM, and you get that VM, and you're running on the server. And so there's security issues that we can mitigate with the DPU when we do that, because we put a computer in front of the computer. And this offload, accelerate, and isolate. By isolating, we put all of those infrastructure services in a different domain than the application processing domain. In this case, the application is the game itself. And now we have some infrastructure underneath that that's independent of that. And so that isolation piece is really, really important to be able to protect our infrastructure. And at the same time, we're really giving the gaming user the same experience that they're used to because they're loaded. That game is loading on the machine that they're used to.
Man, it's so funny as you're saying that. It's like it's so funny because it's like we're so focused on hyper converging our network a little bit. Like we've gone from having it displaced on different hardware to having it on one piece of hardware. Now we're looking at, okay, it's too much. Let's separate it in software now. Let's give them some space, give them some breathing room. That's kind of the direction we're going now, right?
Yeah, that's right. So, and it's that you've gotten hit on exactly a super interesting point about the isolation. I had talked about the security benefit of having separate infrastructure and application processing domains. So you're running your application on the CPU and the DPU, and then your infrastructure is running on the DPU. That gives you this security benefit, but it also gives you an operational efficiency benefit. And as an example there, now I've decoupled my application from the underlying infrastructure. And it may be that, in our case, we design chips. We have a lot of EDA software for Synopsys and Cadence and Mentor to design chips. And they have dependencies on the operating system. And so we may want to add a new version of the Linux kernel. And we can't do it because of the application is dependent on a specific version of the kernel. When we decouple these, now we can actually run at different paces for our applications and our infrastructure. So if there's a new security patch that we want to put on the infrastructure side, we do it. It's independent of whatever the applications that are running. We just eliminate all of those dependencies. When we talk to our own CIO, that's what really excited him, is the operational efficiency that we gained by decoupling. So when you mashed everything up with SDN, it turns out there's some downside to that performance, but also you end up with those tie-in between the application and the infrastructure. And now we've decoupled that again.
So when you're saying that, it just screamed to me microservices, right? Like everyone's containerizing things and separating things, but you're doing this at more of a hardware level, but all in the same area. That's interesting. That's really interesting. No, I did see something about a partnership with VMware and Dell and VMware's cloud foundations. Can you talk? It's probably a rehash of what we already talked about, because I know it's the same stuff. It's your DPUs on the server, offloading, isolating, accelerating. But is it any different with the VMware Dell relationship?
Yeah, so VMware is a great partner, and obviously Dell on the hardware side. And so we really did two different things with VMware. First of all, was on the AI side. Historically, our AI has been available running as accelerated computing on the GPUs, but primarily for the sort of Linux environment. What we did was the announcement of what we call NVAIE, which is our platform that runs on VMware. So it's all of our AI in a virtualized VMware environment. And that's super important because really VMware is the operating system of the enterprise. And so now all of a sudden you can take your VMware environment and the way you virtualize things and manage things, now you can run AI applications, all the Nvidia AI applications that we have, whether it's Clara for healthcare or Isaac for robotics or natural language processing with our Reba platform, Metropolis is our smart cities platform. All of that can now run on VMware. So that was the first thing we did. And the second was called Project Monterey, which is taking that offload, accelerate, and isolate, taking the VMware environment and putting it onto our Bluefield DPUs. And so together, the two things are super powerful. You get AI and you get this split and offload, accelerate, and isolate in a familiar VMware environment.
Okay. So I have a few questions on that, because that sounds so cool. First of all, the AI stuff is like, it's over my head, but it's amazing, because like I know what it does, but I don't know what it does. Secondly, the VMware side. So I'm very familiar with VMware and how you can carve out and use CPUs and share them amongst your VMs, storage, networking, everything. How does that work with DPUs? What's it look like when you're actually like using ESXI and vSphere and everything?
Yeah, so that's a great question. And the answer I think you'll like. I hope so. It looks exactly like you're used to. It looks like vSphere. It looks like ESXIO. It looks ESXi, and it looks exactly like the environment that you're used to using. And all we've done now is really take the things, whether you're going to encrypt a channel, you're going to make the same function call to say, hey, I want this to be encrypted. I'm going to spin up a VM and I want it to have access to storage, and I want vSAN, and I'm using some Tanzu containers. All of the things that you're familiar with in the VM environment, we've just mapped those onto the DPU. And where we have an accelerator, you get massively better performance. So it really gives you the best of both worlds. It gives you that familiarity of VMware plus the accelerations that we get from the DPU.
Dang. Okay. So the thing we're talking about that cloud providers are interested in, that we throw up in the cloud and like they're just doing this amazing DPU stuff, offloading everything. We can do the same kind of stuff on like Dell hardware. We can put it in our own data centers, and it's got a DPU on it, and we can use ESXi, vSphere, whatever you want to call it, and it's kind of transparent. Like when we incorporate networking, vSANs, or we're gonna vMotion something, that's using the DPU. We just don't realize it.
That's exactly right. And so one of the challenges there is to make all of that just work transparently, while at the same time taking advantage of the hardware. So we have this technology called RDMA, or RoCE, RDMA over Converged Ethernet. And we can transmit data without using the CPU at all. We do all of the things that normally TCP/IP does in software with packet and sequence number checking and CRCs and all that stuff. We just do it in hardware. But to make all of that work transparently, to make vMotion work over RDMA, to make vSAN work over RDMA, it's a ton of work to actually make all of that plumbing take advantage of the hardware accelerators. But when we do, you get this magical experience. Everything just works faster, better, more reliable. You don't get these long tail latencies, what Google called the tail at scale. We're doing it very deterministically in hardware. So you don't have the situation that software, most of the time it delivers the data with 1 millisecond latencies, but every once in a while you see 50 milliseconds of latency because something's happening in the network.
See, right now I'm just trying to think about how can I implement this into my home and my video editing infrastructure. Like that sounds amazing. I want to take advantage of that. That's a different price point than I'm used to though. That's amazing. So I think we're getting pretty close to. We've covered everything. I think. Is there anything I've missed out, Kevin, that we haven't covered thus far?
Yeah, well, you mentioned your own video environment. Media and entertainment is just loves this stuff because the world is moving from serial digital interface, these sort of bespoke custom interfaces for digital, to Ethernet. So now we have something called SMPTE, which is driving the 2110 on top of the Ethernet. And so as a single 4K or 8K stream can just completely gobble up a 10 gig link. We're talking 2,500 gig links. And it turns out that when you're doing Hollywood production of video, for example, you need really precise timing. You may have tons of different cameras feeding in, and they all need to be synchronized super tightly. And so we're doing that with a technology we have called RiverMax. It's part of our DOCA platform. We just see so much excitement here because everything is going to be networked. Everything's going to be distributed, microservices, containers. And when you're doing that, the data center is the new unit of computing. You need to put it all together. It needs to be deterministic and precisely timed. That's what people are used to in a computer. Now we need to do that at data center scale. And we think you need a DPU to do that.
So many things you just said that I need to unpack. So, so I didn't know that we're doing like production level red cinema cameras that are somehow connecting to Ethernet, and we're transmitting video over Ethernet.
Absolutely, it's very cool. It's really exciting.
Yeah, I love networking all the things. That's really neat. I'm like, yeah, let's run power over Ethernet. Let's power our houses with Ethernet, and now let's connect everything with Ethernet. That sounds amazing. So we're saying like a Hollywood production, they got multi-camera setups, obviously. Like, got all kinds of guys doing all kinds of stuff, but it's networked together with more than a couple 100 gig links, and we're having to use obviously DPUs and DOCA and everything to manage all that to actually make it work without it just dying.
Yeah, and as always, it's the management as well that's the tricky part. Because if it takes forever to set it up and you can't figure it out, then that doesn't work. So just the discovery and all of the protocols, and that's what's great about the DPU. We can run that on the DPU, and it says, "Hey, I just plugged in a new monitor or a new camera," and then you have these agents that are actually saying what's going on. You discover everything, you figure out what it's part of. You can isolate things, you can create clusters, and then you can bring it all back together. The studio of the future is really based on Ethernet and software-defined networking, and the Bluefield DPU accelerates it all.
That's so crazy. It's like you wouldn't think that. I'm like, I love that being in IT, it can pretty much take you into any industry. But I didn't think about it being like that close to the filming of a movie. Like you're right there. That's where the networking's happening. That's amazing. And then containers and stuff. So I'm gonna plead some ignorance here because I don't understand. When you're saying like neighbor discovery and stuff, I start thinking like networking protocols like OSPF, EIGRP. Are we talking about that when we're talking about DOCA and DPUs, or are we talking about something else?
It's not an autonomous thing. It's more like software-defined networking. And the original vision of software-defined networking is you had centralized management. And so you plug something in and it goes talks to its manager and it says, "Hey, I'm here and I'm a monitor or I'm a camera." And the great thing about when you look at production, if you're a Hollywood studio and you're producing something, then you need, as you're editing it, it's all uncompressed. It's all raw. It's all massive files. Every single frame has to be uncompressed. So the amount of data that you're moving back and forth as you're editing this, they need the full uncompressed frames. And then later, when you finally edit it, you run through that compression phase. And then you're finally going to stream it across Netflix, for example, or over one of the other platforms to somebody's phone. But all of that, when you're dealing with uncompressed video, you need super high bandwidth and you need it to be automated. You can't figure out, where's my camera? What was that camera's IP address? It needs to be automated. They plug in the camera, it tells somebody, "Hey, I'm here. What do you want me to do?"
Gosh, yeah, I need to get my hands on some of that for my live streaming. Can I be the first YouTuber that does that? That sounds intense. Wow. Okay. I didn't think that'd be the application. That's really cool. So that was a neat one. Anything else that I've missed? Because this is like a big new world to me. I don't want to miss anything that would be really cool in the video.
Yeah, so I think the other thing is you should look at what we did with our keynote, and we just published sort of a GTC keynote behind the scenes. And one of the things there is we have our Omniverse, which is this digital twin. And it turns out we created a digital twin of Jensen Huang, the CEO of Nvidia. And we created a digital twin of his entire kitchen. And then put it into the GTC keynote, and nobody noticed. It was all AI generated.
Wait, hold on. You mean that? Hold on a second. I was watching that keynote. That guy was AI?
For part of that video in his kitchen. So go back. We could share the link. There was a part of that where we literally scanned Jensen. We created a CG model, and it was AI Jensen. It wasn't the real Jensen. It wasn't even his real kitchen. All of the stuff in there was being generated, and everything, his motions, his face, gravity is being modeled in Omniverse. That's what Omniverse is. It's a digital twin to the point where, frankly, I saw it and didn't know.
Can we just call it the Matrix? I mean, that's what we're talking about right now, aren't we? Let's be honest here. That's insane. I need to go back and watch that now. Because, yeah, I mean, I watched a lot of the keynote, and I didn't skip a beat on that. It all seemed normal. That's hilarious. What a great prank, by the way. Like, that's like, you guys even notice? AI, the Omniverse, you were there.
You were there and didn't even know. And what's really neat about it is that the BMW factory was another thing we showed in the Omniverse. You had real people interacting in a virtual world. You had real people that had XR, they had VR, and they had sensors on them. And then they were acting in a virtual world. So they projected themselves with the headset into this virtual world, and they were picking up things and figuring out things about the BMW factory floor that, rather than build $1 billion factory and then find out it's all messed up and you need to redesign it, or a building, do it in the virtual world first, figure out, optimize there, and then build the real thing. And so this is the future. You asked what the future was. The future is there's going to be a digital twin of everything. And that's what the Omniverse is. And we're super excited about it.
That's so sci-fi. Oh my gosh.
It
That's
is.
so weird. My gosh. A digital twin and omniverse. I mean, I just all this it's like all the sci-fi movies we ever watch is coming true. Um,
Yeah.
Now, do you see like 'cause, like I know obviously this is going to have a huge enterprise use case for so many different uh, areas of companies and everything, but do you see it like hitting the consumer base? Like I know AR VR is a huge thing. Do you see this like accelerating our descent into not living in the real world anymore?
Yeah, so I think it's going to augment the real world. And I think that's the key of augmented reality. I really do believe that, look, the real world's a great place, but there's some things that you just can't do yourself for whatever reason. I mean, we saw things where people that are unable to speak, for example, they're connecting up to their brain and suddenly they're able to speak. There's an example of augmentation. What we're really challenging people to do is think of things that human beings can't do today that we'd like to be able to do, and let's go do that together. Should be fun.
There's just so many things that this applies to. It's like it's mind-boggling because when you
Yeah.
talk about offloading and accelerating and what was the other word? It was offloading, accelerating, isolating. That's what it was. It hits so many industries and a lot of things I'm excited about, like cybersecurity is a big one. VMware, like that's really cool. But then things I didn't even think about, cinema, the Omniverse, like what the chunk, like that's so cool. Anything else? Like any closing thoughts on this, Kevin? 'Cause, like I mean, first of all, I'm impressed by just your breadth of knowledge in so many industries and how this applies to everything, because it really touches everything from VMware to knowing about vSAN and vMotion to movie production. Anything else that we haven't covered that you might want to close with?
Yeah, so I think that you nailed it. We think every business is going to become an AI business. And that's not a statement that's actually particularly bold to make, because all I'm saying is that the businesses that don't become AI and embrace it aren't going to be around anymore, because AI is the most powerful technology force of our time. And the companies that embrace that and start to deliver new services to their customers and be able to operate more efficiently and to use their data more efficiently, they're going to thrive at the expense of other companies that don't. So the reason that it's so broad is because every business is going to become AI. It doesn't matter whether it's healthcare or retail or robotics, manufacturing, distributing, self-driving cars, all of those things are going to become AI. So we're super excited. And I'm learning a ton all the time from the people at Nvidia that are focused on all those different areas. And really our goal here is to accelerate other people's ability to innovate and all of our partners and our customers. So it's an exciting future. We need to make a digital twin of you, Chuck.
Please, 'cause I work too much as it is. My wife would love that. Actually, yeah, a digital twin of my whole production here. That'd be so cool.
Sounds like fun.
Well, Kevin, I so appreciate you coming on and talking about this crazy stuff. I mean, it's really sci-fi. We talked about creating the Matrix. We talked about solving cyber crime with AI and robots. We talked about filming movies with 100 gig links. Like that's so crazy to me. I love that IT can touch every area of life. And I mean, talking about how AI will be the standard for companies now. Like if you don't embrace it, then you'll get left behind. That's crazy. And I know people think like AI, like okay, most people are like it's a negative thing. It's robots taking over jobs and taking over things, and eventually we got Skynet. But that's not the case. It's just accelerating and doing things that, like you said, humans can't.
Yeah.
It's just enabling us.
Yeah, it's like any other sort of technology innovation. It's really going to liberate people. And so I think for the people that are actually looking at their jobs, they should be thinking about, hey, how can I use this? Are there things about my job I don't like that I don't want to do? And how can I leverage this technology and AI to start to do things that I do enjoy doing? So we think that it's actually going to be creative. It's an example of what we've seen before with technology, and we think that there's a tremendous amount of business and creativity that's going to occur because of AI.
Oh yeah, I totally agree, and I can't wait to see what happens. It's going to be kind of nuts. Anyways, thanks Kevin for coming on.
Super. Thanks. I enjoyed talking, Chuck.